Now, to find the equation of a tangent line, the first thing we need to know is the slope of that tangent line. Well, the slope of a tangent is the same as the derivative. So we'll start off by finding the derivative. Now, the derivative formula is f of x plus h minus f of x. Doesn't matter that we have g of x, it's going to be the same process. G of x is x squared. G of x plus h, we'll substitute in x plus h in place of x. We'll FOIL it out. And simplify. To find the derivative, that is g prime, it's f of x plus h minus f of x, all divided by h. So I forgot limit as h approaches 0 in there. Combine like terms, we have x squared with minus x squared. So the limit looks like that now. Common factor of h on top, which can cancel on the bottom. And last but not least, substitute in 0 for h, and we get a derivative as 2x. Now the derivative is 2x, and that is the slope of the tangent. But that's the slope of the tangent anywhere. We're dealing specifically now with the point at 1, g of 1. So to find the slope, we need to take our x, our 1, substitute it into the derivative. So now I'm going to go back to using m, because this slope is now going to be a number and not a function. So slope, we take our 1, substitute in for x, our slope is 2. Now the second piece of this puzzle that we need is this g of 1. To substitute in and to find the equation of a line, we can't substitute in g of 1, we actually need a value. So I need to go and I need to find g of 1. Now keep in mind that g is the original function, that would be x squared. So plug in 1, we have 1 squared, so g of 1 is 1. So really this point at 1 comma g of 1 is actually 1 comma 1. Now to get the equation of this tangent, we have the slope of the line, 2. We have a point on the line, 1 comma 1, so we can use point slope form. This form of the equation of a line. M is the slope, and y1 and x1 come from the point. So when we substitute in, we'll have y minus 1, m is 2, and we'll have x minus 1. To leave this in slope-intercept form has the y isolated. We need to do two things. We need to distribute the 2 on the right-hand side, and then we need to add 1. So there we have the equation of the tangent to that curve.